Hi folks, and welcome to Surface Geometry 1. So in this question we're going to be kicking off drawing a plan view of a roof, okay? And with these kind of questions what you often get is you will be given certain surfaces in them and you will be told the angles that they are inclined at to the horizontal plane. Now when we're talking about this topic it's often referred to as roofs, okay? I suppose because primarily a long time ago it used to be a lot of roofs and you're getting the surfaces, drawn through shapes, getting dihedral angles between certain surfaces. Now when you're talking about a roof, if we just take this simple sketch I did here of a cottage, when you're talking about the pitch, you were talking about what is the angle of that roof there to the horizontal plane. So if I was to look in at that roof, it would look like a V upside down. But what is that angle? Now that angle is often referred to as the pitch. So if a carpenter was putting up a roof in your house tomorrow and he was saying, give me the drawings there, and you know, he could see that the angle is at 30 degrees, 35, 40 degrees, whatever, okay? Another thing we might often refer to when we're talking about this, going through this topic, is the ridge, okay? So the ridge is the top of the roof there. And you probably would have heard that in geography before when you're talking about the ridge of a mountain, okay, where the top of the mountain runs along. So in this question, we have been told there that the diagram is the plan view of a roof. Surfaces A and B have a pitch of 45 degrees. Surface C has a pitch of 40 and D has a pitch of 60. So go ahead, part A, draw the plan and elevation of that, okay? Now, to say to you, auxiliaries is really the name of the game in this topic, I find. There is, of course, always other ways of solving things in drawing, but you will find that it is so beneficial doing the auxiliaries and so simple when you kind of think about why they're working, okay? So A is going to be there, B is going to be there, C is going to be down there, and D is going to be over here, okay? Now, you can see in the question, and sometimes you are assuming things, that the ridge of the main roof is running down along the middle of the roof there, okay? So that's 80 mil, and half of that will be 40, and of course the scale on this is 1:100. So that's 8 meters there, so we'll be drawing that 80 mil, okay? So we'll just do a light line down there at the moment because we don't know where that ends. Now, I know the pitch of A and B, so in order to draw the elevation, this is the main roof, I need to know the height for the elevation there. So we're going to look in at this straight in there and we're going to see this kind of V shape, okay? So I'll just come out here a little bit and we'll set up an X1Y line. Sometimes if we're looking at old solutions to these questions, when I do this auxiliary, I'll just finish this first. It goes up here at 45 degrees, surface A. Surface B goes up at 45 degrees as well. Now that's an edge view of A. This is an edge view of B. And again, linking back all that stuff to the oblique planes, you want to see a surface as an edge view, which we do of A, get a true length line, that's the true length line there. Look along it and you'll see the plane as an edge view. So now, what have I got out of that? Well, I knew the line was going to be running down here anyways. You could assume that from the question. But I have now gone and I have got the height of that roof. So I'll just get a colour there. And we're just marking our height. So this will be our first height here. And we'll be able to take this height now and we'll be able to transfer up there to the elevation. And it is 40 millimeters. Now, D, we're told in the question there, D has a pitch of 60. Because in the question we can see surface D meets somewhere around here, it meets A and B, okay, but we don't know exactly where. So this is also a true length line. So, you know, we're just going to look in at an elevation and see D as an edge view. So, you know, you could draw your arrow if you wanted to. So up you go there. Look in at D now and we'll see that as an edge view. Now, you'll keep finding certain points and then you'll be able to bring them back into other views. So, for example, we have the height there now of A and B. I have an edge view of D running up here. And I can find out now in elevation where those surfaces intersect at the very ridge of top of the ridge of the roof. So you can get X now and you can drop them back down to plan view. And now we have X. So now we can go ahead and we can finish out a nice bit of our roof actually. Okay, you can do that heavy. You can do this guy in heavy now. And do this guy heavy up here. Now, we also have to find C, okay? Now, the only thing we're told about C in the question is that C has a pitch of 40 degrees, okay? Now, you can set up an auxiliary view, looking in this way to find the height, because remember, a lot of triangles are based, or a lot of roofs are based on triangles, okay? So sometimes, if you have a triangle, you can figure out its height if you know its base and the inclination of it. Okay, you could just bring up this line here. You hit a vertical line going up there, you get the height. Sometimes, you know, you could know the height and you could know the base of it, and you'll be able to figure out this guy here, okay, the slope and surface, the length of it. So different ways about, if you have different pieces of information with a triangle, you can figure it out. But we could look in that way and figure out the height of C. I don't need to do that, of course, because similar to D, we're going to look straight in here. Bring up that guy there. Get your protractor. Mark off 40. And there is the top of C. Now, we have actually our elevation finished, but we still don't have the plan view finished. And you might say, well, how am I going to get this down to here? Well, what you'll do is, I'll get another color now. We're going to take this height here. We know the height of C. I call that H2. So what you can do to finish out your plan view, you can take that height there and we can mark it off over here, because we know that point hits A and B up around here at a certain height. So I'm transferring that height now. If I bring in that height, I will find that point there, and we'll call it J. Okay, so when you have J there, you can now bring it back into your plan view. And that is J. So all the time, folks, you're going to be finding a piece of information in one view, maybe putting it on another view. That'll get you another point of information that you need. Bring it back in then, and you'll keep doing that with the likes of J there. Okay, so we've got the height of J there, transferred it over here, okay, onto our first auxiliary. Okay, so at that point, at that specific height, J, the surface C, and that point J would hit the surface B there, and then we're able to bring it back into plane. Okay, so that is the plan and elevation done. Now, the next thing we're asked for there then is to develop the surfaces B, C, and D. Okay, so to develop them, they're quite easy. So we have a true length line here. We can use this line here now as a hinge point, okay? So if we're looking directly along that line there, we're going to see that point. And what we can do there is we can get our compass. And we can knock D down onto the ground. If you drop this guy down, bring this guy out, that'll get you X1 out there. And that'll get you the surface D. That's true shape. TS of D. Next one we're asked there was for the true shape of C. Okay. Now there's different ways, places you could use this line as a hinge point, flop it down, okay, or you could flip it back this way. So if you use this as a hinge point, you could flip this around up to here onto a line that's up here, level with the XY line, and drop it down. So I'll probably use this one here, okay. And we're doing the exact same thing we did with D. Drop it down, bring it out. Bring them out as far as there. This will get me the true shape of C. Now I'll colour them in a minute to make them stand out, okay. Last one there, then I want to, we're going to ask to get the true shape of B, okay. Now it would be quite unusual to be asked for this amount of developments, but it's just the practice of getting the true shape. So I have an edge view of B there. I'm going to swing it around. And this is the line we're using now as a hinge point, okay? So this guy is going to come out to here. And the top X there is going to come out as far as here. And I have one more point to bring around actually there. I have to bring around J. Now I'll probably just colour in two of these because these develop, you know, getting the true shapes, these will be lapping on top of each other. Now, so that will get me J1. And I just bring across X1 here in this. Now we'll take a couple minutes and we'll colour them in there. Okay, so the development of C was there as well, but I didn't colour it in because they were kind of merging in on top of each other. In actual fact, if you wanted to, you probably could. Actually, we'll have a go at it. Now, last thing then, folks, we're asked for a dihedral angle, okay? So get the dihedral angle between surfaces B and D. So the first thing you need to do there is you need to identify the line of intersection, okay? Now the line of intersection here is this red line. It's the line common to both planes there. So as usual from oblique planes, first thing we need to do, we need to look in at this and we need to see it as get its true length. Now I'm going to bring 1 point from each plane call them S and T. Set up your X1, Y1. So X is a height of 40 there. This guy is on the ground, okay. That's my true length of the line of intersection. S and T have no height. If you were to bring them up, they'd be here and here, okay. So S and T. And now to get that dihedral angle, look down along the true length line there. Now, you're measuring back from the X1, Y1 line, okay? And you always know you're measuring from the right place because the XY line is parallel to the line of intersection. Only when both points are the same distance to an XY line can you end up with a point view down here. So, get my compass or your ruler. That is that line now as a point view. That is S. That is T. That will get you the dihedral angle between the surfaces B and D. So that's that question, folks. Hope you found it useful. Take care. More videos to come soon.